Tave, and this is my screencast for Project 2 of Operating Systems. As you can see in front of me, I have the header file for the Memory Manager class. Here are all the functions that are declared as specified in the project document, and the two allocator functions for best fit and worst fit. The way the Memory Manager keeps track of the memory that it allocates is with the hole tracker and item tracker maps that track the holes and the items allocated in the block respectively. So these maps are from int to int, and the first value is the offset in words from the start of the block, and the second value is the size in words of the item that's being kept track of. And memory is the memory that's allocated. So now going through all of the functions, this is the constructor for Memory Manager, and it takes in word size and the allocator function assigns those respectively. And because when it's initialized, it doesn't have a block already set up, or it's not supposed to, memory is set to null, hold tracker and item tracker are set to empty maps, and max words is set to 0. For the destructor, all that's necessary to do is to delete the memory that corresponds to the block that's been allocated. For initialize, this is the function that is called when we want to initialize a new block of memory. If size in words, which is supposed to be the size of the block in words, is greater than the value specified in the project, then nothing is done. But otherwise, we set max words to the size in words, delete whatever memory was before, and set memory to a new character array that's the specified size in bytes by doing size in words times word size. And we also create a new hole in hole tracker that corresponds to the whole block. Item tracker would still be empty since there's nothing in there. When we shut down a block of memory, we delete memory, set memory to null, and again set max words to 0 and clear the hole tracker and the item tracker. Allocate is fairly complicated because it has to manage tracking the holes and items as well. But basically, it just uses the allocator function to get where it needs to start allocating the memory and uses that to figure out how to update the hole tracker and the item tracker correspondingly. And then it returns the first address of the allocated space. Free also is fairly convoluted because it needs to update hole tracker and item tracker. But other than that, it's fairly simple. It recalculates the start position, which is the word offset from the beginning of the block from the memory addresses. And it doesn't return anything, but it updates hole tracker and item tracker to reflect the essentially new hole being created because the memory is being freed. Set allocator is a very straightforward setter that just changes the allocator function. Dump memory map creates a file with the memory map of the current state of the block as specified in the project instructions. Get list also it returns a list that is specified in the project instructions in the correct format as a unsigned short array to match because the tester function expects it to be 16-bit. Get bitmap again just gets exactly what the instructions of the project specify, and it returns a bitmap in the correct format, and it is a array of unsigned characters. Then get word size, get memory start, and get memory limit are just very simple getters and setters. Get memory limit needs to return it in bytes, so it just multiplies max words times word size. And these are the allocator functions as described in the project. This just returns the smallest hole that the thing fits in, and this returns the biggest hole that it fits in. Now I'm going to quickly demo the tests running. So we have to go into Memory Manager, use the make file to compile it, and then we can get out and run the test for item canvas, and we can see that we get 38 out of 38.